Section 4.4 is trig functions of any angle. What this really just means, we're going to leave quadrant 1. We've been hanging out in quadrant 1 for the first 3 sections of this chapter. Now we're going to go to different quadrants, but we're basically going to do the same thing. So I happen to draw XY in quadrant 1 to start with, so we can come up with the general rules for this. This is not a unit circle. I'm going to go ahead and make this a right triangle. Because the coordinates of that point is x, y, then the horizontal distance is x, the vertical distance is y, and we're going to call the radius, or the distance from the origin to x, y, r. Okay, if I'm looking at this triangle right here, the sine of theta is the opposite over the hypotenuse, which is going to make it y over r. The cosine of theta is adjacent over hypotenuse, so that's x over r, and the tangent of theta is y over x. Okay, this is just like the unit circle, except now the r is not 1. Because the r is not 1, we might have to calculate the r. If we calculate the r, we're just using the Pythagorean theorem. So if I look at that right triangle, according to the Pythagorean theorem, x squared plus y squared would equal to r squared, and we could solve for r that way, which is why your book tells you that r is equal to the square root of x squared plus y squared, and we always take r to be non-negative, which is why there's no plus or minus there. Okay, so for example 1, we're going to let 6, negative 8 be on the terminal side of theta, and we're going to find sine theta, cosine theta, and tangent theta. I'm going to use the formulas we just wrote down to find sine, cosine, and tangent, but then I'll also draw a picture for people who prefer the picture. Okay, before I even start, it says 6, negative 8 is on the terminal side. What that's actually just telling me is that this is in quadrant 4 because the x is positive and the y is negative. Okay, to find sine, cosine, and tangent, I actually need the r. So I'm going to use the formula that it just gave me for r. It says r is equal to x squared plus y squared. Or you could use Pythagorean theorem. Okay, so r is going to be the square root of 100, which is 10. And we always make this positive. We'll never assume it's negative. If there's a negative, it's going to be related to the x or the y. Okay, I'm going to go ahead and use the formulas from above to find sine, cosine, and tangent. So the sine of theta, according to our new found rules, sine of theta should be y over r. Our y is negative 8. For the r, I just calculated that to be 10. So if I simplify that, I get negative 4/5 for my sine value. Okay, let's see for cosine. Cosine is x over r, and my x coordinate is 6, and the r I found to be 10. And then when I simplify that, I do get 3/5. And then tangent is the y over the x, just like it is on the unit circle. I didn't even need the r for that. This simplifies to negative 4/3. Okay, if you're wondering what this looks like if I were to draw a picture, because I could also draw a triangle for this. If I just estimate about where 6, negative 8 is, it's somewhere down here. And if I wanted to draw a picture, I would draw a right triangle going like this. The x distance is 6. The y distance is, well, it's 8, but we were going to put negative 8. And then if I use Pythagorean theorem to find the r, it would be 10. The angle I'm looking at is I'm actually considering theta being this full distance, but because the ordered pair for this is the same as this angle, I would use this angle to find sine, cosine, and tangent. Okay, I would get the same answer, but you don't have to draw a picture. You can always use the formulas instead. Okay, example 2 is going to be similar to problems we've already done before, where you're given the sine, cosine, or tangent, and then it's going to be up to you to find the other ones. But we do have to consider the quadrants and the positive and negative signs now that we've left quadrant 1. Okay, so for example 2, it tells me that the tangent of theta is negative 1/2, and the sine of theta is greater than 0. It wants me to find the cosine of theta and the cosecant of theta. Okay, let me consider what I know so far. Okay, I know that tangent is y over x. Okay, I don't know if that negative applies to the y or to the x because it cannot apply to both. So I'm going to consider the rest of the information it's telling me right now. Okay, now it's telling me that the sine of theta is greater than 1. What is that really telling me? It's telling me that the y is positive. So I know the y coordinate has to be positive because the sine of theta is greater than 1. If I'm thinking about the quadrants, because eventually I am going to have to consider all the quadrants, the y is only positive in quadrant 1 or quadrant 2. So I know I'm down to one of those. This also told me that the y is positive. So because the y is positive, it must be true that this is positive 1 over negative 2, so that I can make sure that the y is positive, which means the x is negative. So one ordered pair that is consistent with the tangent of theta being negative 1/2 would be the ordered pair negative 2, 1. Okay, now that I look at negative 2, 1, which quadrant is negative 2, 1 in? Negative 2, 1 is in quadrant 2. So now I know that I am in quadrant 2, which will help me later when I'm checking my answers. Okay, because I have an ordered pair, I can calculate all these trig functions without doing any other work. Okay, because I have the x, I have the y, I'm going to go ahead and find the r. Okay, so for r, I got square root 5. Okay, let me consider what I'm actually trying to find. I need to find cosine. So let me find cosine first. Okay, what is cosine? Cosine is the x over the r. So the x I used was the negative 2. The r I just calculated to be root 5. And of course, I am going to rationalize this. Okay, I got cosine. Now I need cosecant. Okay, cosecant is the reciprocal of sine. So since sine is y over r, cosecant must be r over y. So what did I get for r? R is root 5. The y coordinate I chose was 1. So I got root 5 over 1, which means the cosecant is just square root 5. Okay, for example 3, we're going to do the same type of thing. This is just another way they can give you the information. But my goal is going to be the same. I'm going to try to pull out an ordered pair because with an ordered pair, I can calculate any trig function I would like. Okay, so the terminal site of theta lies on the line y equals 2/3 x, and it is in quadrant 3. Find the sine of theta. Okay, now there's several ways I could do this. Okay, let me just think about the situation first. Okay, y equals 2/3 x is a line. The y-intercept 0. And if I go up 2 over 3, and I draw my line, okay, I want the terminal site of theta lies on this line, and I know it's going to be in quadrant 3. Okay, so this is telling me that theta is going from here all the way to quadrant 3. Okay, do I need all that information? No, I just need one ordered pair on that line that is in quadrant 3. Okay, so if I can pick any point over here, if I know a point on the line that's easy to get, I can pull that point out and use that. If not, I can plug in an x value and get the answer that way. Okay, so I might consider the slope because I went up 2 over 3. I could have also gone down 2 and left 3. If I went down 2 and left 3, then one ordered pair on this point would be negative 3, negative 2. So negative 3, negative 2 is one ordered pair I could use if you want to kind of think about the graph. Okay, but it could be any ordered pair that's in quadrant 3 and is on that graph. Okay, so let me think. If I want to pick a random ordered pair in quadrant 3, I just need a negative x value. I could, if I don't like fractions, I might pick one that doesn't involve fractions. But I'm going to pick, let's say I pick negative 1. Okay, if I plug in negative 1 for x, 2/3 times negative 1 is negative 2/3. So -1, -2/3 is also on the line of y equals 2/3 x, and it's in quadrant 3. So I could use that ordered pair. It does not matter which ordered pair you use. You'll get the same answer no matter what. But because this one looks easier, I'm going to go ahead and use this ordered pair. Okay, after all that, that's all I wanted was the ordered pair. Because I'm using the ordered pair -3, -2, I'm going to go ahead and find r. And if you want to try it with -1, -2/3, you might want to try it just to show that we're going to get the same final answers, even though we'll get a different r. We'll get the same ratios. So x squared plus y squared. Okay, r is root 13. What am I even trying to find? I'm trying to find the sine of theta. So sine of theta is the y value. Because I used that ordered pair, I have -2 over the r, which is -2 root 13 over 13. And if you had used a different ordered pair that met the qualifications, you would get the same answer. Okay, the second part of 4.4 is going to be solving basic trig equations, and we're just going to use the unit circle. So there's not going to be work to show, well, there might be a little bit sometimes, but this is just kind of trying to figure out the answers within the indicated domain. We'll start solving for real in chapter 5. Okay, so for A, it's telling me that the sine of theta is -√2/2. I want to figure out what theta is. Okay, so I'm going to think about the unit circle. Okay, if the sine of theta is -√2/2, it's telling me that the y value is -√2/2. Okay, if you have your circle in front of you, look at your circle for where the y value is -√2/2. It's going to be right here and right here. Okay, before I write my answer for what theta equals to, I'm going to consider my domain restriction. Domain restriction is I have to go from 0 to 2 pi. Okay, this is saying it can equal to 0. It cannot equal to 2 pi, but it could equal very close to 2 pi. Okay, so let me consider those two locations in a positive direction. So 0 going here, that's 5 pi over 4. And then if I kept going to this other spot over here, this would be 7 pi over 4. Those are both the two locations where the sine of theta is -√2/2, and they stay within 0 and 2 pi. Okay, so for B, it says the cosine of theta is -1. I'm just using my unit circle. Okay, so where's the cosine -1? That's the x value. Where's the x value -1? The x value is -1 over here. Okay, what is theta at that point? That's pi. Is pi between 0 and 2 pi? Yes, so my theta is just going to equal 2 pi. And in this case, there happens to only be one value that works. Okay, for part C, it's similar, but the domain is going to be a little different. And that's where you're going to have to think a bit about. Okay, this is cosecant. I'm going to flip this. Cosecant is the reciprocal of sine, so this is really telling me the sine of theta is 1/2. And that's a little bit easier for me to work with when I'm looking at the circle. Okay, and you don't have to draw it. I like to see. Okay, so I want to see where the y value is 1/2. So that's going to be somewhere here and somewhere here. I am going to go from 0 to 4 pi. So let me think about this. Okay, so I know that this is pi over 6, and that's between 0 and 4 pi. I know that this is 5 pi over 6. Okay, now they're telling me that I can go around twice and get to this location. So this is pi over 6. This is 5 pi over 6. They want me to keep going. This is 12 pi over 6, so this is 13 pi over 6. (13, 14, 15, 16, 17 pi over 6 is also less than 4 pi. They want me to go around the circle twice and pick up all my answers along the way. Okay, if you don't like counting, that's okay. I got pi over 6, 5 pi over 6 from my first revolution around the circle. It tells me I can go around twice. So if I didn't want to count it, I could do pi over 6 plus 2 pi, which is pi over 6 plus 12 pi over 6. So that tells me 13 pi over 6 is going to have the same sine value. And then the same is true with my 5 pi over 6 answer. If I add 12 pi over 6, I get that there's a coterminal angle at 17 pi over 6. So that has the same sine value, and that's between 0 and 4 pi because it told me I could go around the circle twice. Okay, now for the next one, it says the tangent of theta is -1. Tangent requires a little bit more thinking. Okay, tangent is y over x. So I want to figure out where the y and the x basically all cancel, but I'm going to have a negative. So that always happens at those weird root 2 over 2, root 2 over 2 spaces. But I need to be careful because I want them to cancel to a -1. So what quadrant am I in for that? Okay, this one, no, that's positive, positive. This would work because that's negative, positive. This is negative, negative. This is positive, negative. Okay, so it looks like there's 2 locations on the circle where this will work, but they're giving me this weird domain that I must respect. Okay, let's see. Negative pi to pi. Okay, I'm going to do the positive part first. Okay, 0 to pi is just telling me if I go this way on the top half of the circle, what answer am I going to get to? Okay, so if I go this way around the top part of the circle, I get to 3 pi over 4. So that's one of my answers. Okay, but they tell me I can't go that way and I can't go past pi, but I can go backwards pi, so I can go in the negative direction this way. And I need to pick up my other answer going that way. Okay, so if I go that way, I want to go down to that point, down to here. Okay, if I go down to here, I'm going in the negative direction, and in this case, I'm going negative pi over 4. Okay, I do know that's called 7 pi over 4, but 7 pi over 4 is not within my domain. Negative pi over 4 is within my domain, and it has the same tangent value. So these are my 2 answers. These are the 2 points when I'm staying from negative pi over pi to pi. Okay, 2 more. Okay, this one says secant theta is -2 root 3 over 3. Okay, I am going to do the reciprocal because then it's easier to search for on the unit circle. Okay, that doesn't look right. Let's rationalize it. Okay, I'm going to cancel out the root, no, not the root 3's, the actual 3's. So I'm left with negative root 3 over 2, which I like because I could find that on the circle. Okay, cosine is negative root 3 over 2, so that's got to be x is negative, so here and here. Okay, what's my domain? 0 to 2 pi. That's good. That's the nice normal one I'm used to. That's my unit circle domain. So that is 5 pi over 6 and 7 pi over 6. Okay, last one, cotangent. Let's see, cotangent is, I could flip it to tangent, but I'm okay with this. It's x over y. Okay, there's no spot where it is root 3 comma 1, but there is a spot where it's root 3 over 2 comma 1/2, and then the 2's cancel out. So I'm looking for that spot right there. And I'm going to think about this carefully. Okay, so that happens, x is root 3 over 2, 1/2. That's going to happen over here. What is that? That's pi over 6. Okay, now this happens in another quadrant too. Because if I go to quadrant 3 and I make this negative, negative, then I'm still going to get negative root 3 over 2 over negative 1/2. It's going to simplify down to positive root 3. So that answer is also going to work. So negative root 3 over 2 1/2 is down here. And that's 7 pi over 6. And I stayed within my 0 to 2 pi. So those are the 2 possible answers for the cotangent of theta equals root 3.